Okay, so let us continue with one special case of homogeneous equations. Okay, where there is some variable involved and we can do a change of variable and get the required of form of the normal form of a homogeneous equation. Okay, so now this actually refers to something which you are not studied in geometry. Okay, you will remember the equation of line, right? Just a revision a little bit. How do you write the equation of a line? The general form you'll know is y is equal to mx plus c. Okay, but you can also write the equation of a line in this format, right? Ax plus by plus c is equal to 0. Alright. So now if I give you two lines, a1 a1x b1y and c1 is equal to 0, and another line a2x b2y and c2 is equal to 0, right? Assume that these are two lines given to you, right? How do you find the point of intersection between these two lines? See, any two lines are given in R2, right? On a plane, if you are given any two lines, what are the possibilities involved there? Either both those lines are parallel or they are intersecting each other, right? So the parallel case is a little bit obvious, that if they are parallel, what will be happening? If they are parallel, their coefficients over here should be kind of similar or multiples of each other. Okay, this can be little shifted. This will not be similar. Like if you, like for example, this line, if you have this line ax plus by plus c, okay, the next line you can draw one more line parallel to it. This will have ax plus by plus d over here. Okay, this constant will change. Okay, if it is same, then it's basically the same line. Okay, but also you can even have a scalar multiple of this. Okay, so you can even take 2ax and 2by, okay, is equal to d plus d is equal to 0. So that will also give you a line which is parallel over here. That will be a different line, not the same line. Okay, so now if this is not the case, that they are multiples of each other, the thing is that they have to intersect somewhere, right? There is no other possibility. Either two lines are parallel or they are intersecting with each other, right? So how do you find the point of intersection now if two lines are given to you? What is the technique you will follow? Okay, let me frame the question the other way around. What do you mean by two lines are intersecting? What do you mean by point of intersection? That point of intersection will lie on both the lines, right? So that point x comma y should satisfy both the equations, right? So basically what are you looking for? You're looking for something what you call as a common solution of both the lines, right? Right? So now here you have a system of equations in two variables. Do you all know how to solve this? This is easy now. You learned how to solve equations, no? This, I think this is taught in school, right? Okay, so we find that you simplify these equations and we find the points over here. Let me give you an example on this first before proceeding. Let us do one example. So if I take the lines 2x plus 3y is equal to 5, I'm just keeping 5 on the other side, and 4x plus 2y is equal to 3. Take these two lines. How will you solve this system? You will have learnt elimination method, no? Where will have reached in algebra syllabus, basic algebra? Huh? Oh, still no learn sets. There is one more shortcut technique you will learn over there. That is basically that same thing what else said. What else said? Basic, what do you call that? Elimination, no technique, yeah. So you all can do that, but in a little different way. So see, you all write this in a matrix form. 2, 3, 4, 2, 5, 3. Okay, write a matrix, write the coefficients of x and y without x and y, okay, and put a bar over here to write the RHS. Okay, this is not a bar separating the matrix. This is a how much matrix? 2 cross 3 matrix. Okay, the last row will always be for this thing. So now, oh, you have no row operations, no? Oh, you will have not studied anything over here. Anyways, we can come back to this technique later on in the semester. Anyways, we'll go by a Gauss elimination only. Yeah, how do you all do that, by the way? Yeah, what is the approach which you all follow? Hmm. Hmm. So what will that give you? The first equation you want to multiply by 4 or this side. Okay, I'll teach you all one more method here, which is kind of similar, but this will can be generalized later on for something else. Okay, so what I'll do now, I'll multiply the, no, if I do that now, again we'll get stuck because you all might not know something later on. Hmm. No. See, let's look at it like this. Let's try to, you have your system of equations over here is going to be the ones which we are going to solve over here. We are going to have two variables, okay, and two equations. Okay, so two equations and two variables. Okay, what I'm teaching can be used only for that. It can be extended later on, but the way I'm teaching all right now, it can be used only in this case. So what do you do now? Take this first element and try to eliminate this number below it. Okay, so the one exactly below it. So what I'll have to do? I'll have to, from the second equation, I'll have to call this as equation 1 and call this equation 2. So you do this equation 2 minus 2 times equation 1. Okay, what will that leave you with? You will have your first equation as it is standing there. Second equation will become 2 times are subtracted, so this one has become 0. Minus 6 times minus 6 plus 2y, so this will leave you with minus 4y over here. This was going to be minus 10 plus 3, so this is going to leave you with minus 7. I didn't get what I did. I subtracted the, wait, I'll show you the step. So this will become 2 times the first one, no? So 4x minus 2 times the top, this thing. Well, let me write this down and then let us cancel out 2y. Okay, minus 2 times the top one, that is 2x plus 3y. And this is going to be 3 minus 2 times 5. Okay, now clear what I'm doing. So what will this simplify to? So the first equation I'm keeping as it is. Leave one line gap. So 2x plus 3y is equal to 5. Second equation, this will become 4x. 2x is there, not 2 into 2x, that's 4x. So this will cancel this out. And this is 2y minus 6y. So this will leave you with minus 4y. Clear? Okay. And this is 3 minus 10. This will leave you with minus 7. So what do we get now? What do we get now? We got one answer already. So this will imply that y is equal to, take this 4 down the side, minus 7 by minus 4. So you'll get minus plus 7 by 4. Clear? We got the value of y, substitute in the first one. So 2x plus 3 times 7 by 4 gives you 5. Now you can simplify this and get the value of x. Okay, this is going to be 2x plus 21 by 4 is equal to 5. You can eliminate that 4 from the denominator by multiplying 4 on both sides. So this will become 8x is equal to 20. 8x plus 21 is equal to 20. Call this as substituting. So what are you going to get? X is equal to, you're going to get 8x is equal to minus 1, taking this on the other side, and x is equal to minus 1 by 8. Okay, basically this is the same thing what I have learned, I've just done it in a different way. Okay, like this is kind of an ordered way of doing it. So what I've done is, you all know what's a triangular matrix? You know that name triangle? It's done for you all in 12th. Upper triangular and lower triangular matrices. You know what that name? Diagonal matrices all know, no? Yeah, so diagonal means what? You all have a square matrix, see? You will have a square matrix in this A, B, C, D. Okay, if you have a square matrix like this, only if this is the regular square 2 by 2 matrix, if you have only this, you will have only this over here, that is A and B, 0 and 0, right? This is called as a diagonal. This one you all know, diagonal matrix. So same way, you all can even have two more matrices, that is A, D, D. This is called as a upper triangular matrix. Why it's called upper triangular? Because the numbers above the diagonal are non-zero and below the diagonal are 0. Okay, and this is upper triangular, and then there is something called lower triangular also, that is A, C, A, C, B it was. B 0. Okay, this is called as a lower triangular because all the elements below the diagonal are non-zero and above that this thing are 0. So when I say triangular, I am referring to either one of this. So this is called as a upper triangular, because you get a triangle shape inside, triangular, and this is called as lower triangular. When you do this in 3 by 3, you can see the thing better. A, B, C, E, F, G, 0, 0, 0. So this is also an upper triangular matrix, right? Okay, and can you see that there is a triangle formed here, and the ones below that they actually form another triangle of zeros. Okay, so this is upper triangular for 3 by 3 matrices. Then one theorem is there that every matrix given to you, every square matrix can be written as a sum of a upper triangular plus a lower triangular matrix. This result you will see. How can that be done? It's very simple. How will you do that? How can you write this? You have, if this is given to you A, B, C, D, how will you write it as this thing, upper triangular plus lower triangular? Directly it's not so this thing, no, because see what will happen if you add this two up currently. D plus 0 will give you D here, C plus 0 will give you C here, right? But what will happen to the other two people? This will become a problem, no? It will come A plus A and this will come B plus B. So what will you do to balance it out? You write this as A by 2, A, B by 2, A by 2, B by 2. So how to write a matrix as a sum of upper plus lower triangular? Just split out the entries as above the diagonal, below the diagonal, and the diagonal elements to divide by 2. Okay, so that gives you this result. I think so this theorem you will prove now if you have not proved this semester in that course, algebra course. Okay. So yeah, anyways, what I have done is what I have done was, I was given a equation there, right? If these are the coefficients of the equation, I eliminated this one coefficient from there. Okay, yeah, these are triangular matrices, no? So in general, when you're talking of equations, you can also talk like this: a1x plus b1y and a2x plus b2y. Okay, forget the RHS person on this side. Okay, what I have done over there is I eliminated this fellow from the equation, right? The method which I was doing. So I left out with a1x b1y plus some new, this thing will come here. I'll call it as b star, because it's not the same b2. Something happened here. You did b2 minus something and you got this y, right? So this now is a triangular matrix. Okay, if you look at it in that format. Okay, so for that reason, this kind of method is referred to as the Gauss elimination method. Okay, it's same as what you have studied, but only thing I'm kind of doing it in an order. Okay, in a very specific order I'm doing it. Okay, so what we have learned here is to find the point of intersection. So what is the point of intersection here? That was 1,8, what is the other point? 7/4. Okay, so this is the point of intersection of both the lines. So now, just giving you all a better understanding over here. This you all will be studying in geometry. Geometry paper is coming for you somewhere later on. Usually students study geometry before differential equations, but now thing has been inverted a little. So let me just explain the geometry part here. Here if we have a line, some properties of line which all know, that only I'll tell you first. Right, and here you have one more line. So if this equation of this line is y is equal to mx plus c, what should be the equation of this line? They are parallel, that you can see now. What is the thing which will change? What will be the properties? Will the slope be the same of both the lines? If two lines are parallel, what are their properties? I'll did this online. What are some properties of parallel lines? I don't know. Easy things are in this one. I studied this chapter online or what? Only online that time. Okay, never mind. One essential property about parallel lines is their slopes are equal. Slope you'll know at least, know what is slope I'm talking about here. Slope is the angle which the line makes with the positive x-axis. So okay, can you clearly see that the angle involved here is same with regard to the positive x-axis? Okay, the bend at the same level, no, compared to the positive x-axis, so they have the same slope, right? So this line also down, that one's equation also has to be y is equal to mx. Now what about the remaining part now? Because slope is same for both the lines. If they are parallel, slope is same, right? Now what about the constant here? What should be the constant? Notice specifically that this line is passing through the origin. So what should be the constant? What does this constant represent, by the way? It has a name. What's its name? It's called the y-intercept, no, not x. It's the y-intercept, no, that point C, that value C is basically the y-intercept. Why I'm calling it the y-intercept? If I put x is equal to 0, what happens there? In that equation, you get y is equal to C. So what that means? That's the point where the line crosses the y-axis. Okay, so that's why we're calling it the y-intercept. X-intercept is basically the place where the line crosses the x-axis. How do you get that? By putting y is equal to 0. Okay, you put the opposite fellow to be 0. Okay, why do you put the opposite? Like on this is the y-axis, right? On the y-axis, the x coordinate value is 0. Alright, so this I'm putting x is equal to 0 here, and I get y is equal to c. So here this coordinate over here is c comma 0. Okay, here it is 0 comma 0. So what should be this value over here to be added? 0. Right now. Anyways, in general, any line passing through the origin, this is a property. Any line passing through origin is of the form is of the form y is equal to mx. Okay, this property also no. This might have been done for you indirectly in 11th. Okay, that any line passing through the origin is of the form y is equal to mx. Okay, and if it has some constant over there, that means it's not passing through the origin, it's passing through that intercept point. Okay, you'll have to sit and calculate that intercept. Okay, yeah. So now what I'm doing here is now this much is clear now. So what is one advantage here is when a line passes through the origin, it does not have a constant term involved here. Okay, so that is what I had to tell you. Okay, so any line passing through the origin is of the form y is equal to mx. So now next what I'm doing is, let's go to the what we were specifically working out with here. So now assuming that this is my x and put in white. Okay, now in this I have my two lines. This is my one line and this is my another line. Okay, which I'm trying to work out with over here. Okay, so this was my ax1 b1y plus c1 is equal to 0. Okay, now you will understand the relationship between this now. If my equation of a line is given like this, ax plus by plus c is equal to 0, what you are going to do with this? You can convert it to that form, y is equal to mx plus that constant c. What are you going to do? We're going to write it as by is equal to minus ax minus c, right? Take this term on this side and this term. Okay, this is the standard form, no? So converting to the standard form, what I'll have to do, take ax on the other side, minus c on the other side, and write this as y is equal to minus a by b times x plus minus c times c by b times 1. This will be the constant. Okay, so what is the slope of your line? Slope will become the value of m. This is the slope, that will become minus a by b, and the y-intercept is equal to minus c by b. Clear now? So if you are given a line, because we won't be talking always in the standard form, our lines will be given to us in this form. Okay, we have to convert to the standard form and understand its properties. Clear no? So this is how we convert to standard form and get the properties out. Okay, so now this was the original line, this is the standard form of that given line. Okay, clear? Yeah, so same way we are given another line here, and this is a2x plus b2y plus c2 is equal to 0. Okay, and this over here is their point of intersection. Okay, we'll call it by the name h comma k, because use this alphabets h comma k. Okay, and this is my point over here, 0 comma 0. Clear? So now what do I know so far from my geometry? This thing about lines is that if a line passes through the origin, its equation is nice. Okay, it does not have a constant term extra added over there. It becomes y is equal to mx form, right? Any line passing through the origin can be written as y is equal to mx form, right? That's a very nice form over there and very easy to deal with. Okay, that constant c kind of creates trouble for a line. Okay, and so lines passing the origin are always nice, but these two lines which are given to us, the green line and the blue line, they are not passing through the origin, right? So what we do is we wished that they pass through the origin. So what we do is we use one trick over here called as the change of origin. Okay, so what do we do in change of origin? We change the definition of the origin point. So what we do is we do a change of variable and the position of the origin changes. Okay, so what do we do is your small variables are x and y. These are your given variables, right? And you have written your equation of line everything using this small x, small y, right? So what I do is I define a new variable over here. I define new variable that is capital X. Define capital X as small x minus h and capital Y as small y minus k. Okay, so what you are doing by doing this? You are changing the origin, because see, if I put the small x as small h as h, what will I get? Capital X becomes h minus h, that is 0. Capital Y will become, if I put y, small y is equal to k, capital Y will become k minus k, that is 0. So what is basically happening here is when small x comma y is equal to h comma k, right, we get capital X comma y. What will this become? 0 comma 0. Okay, so what I'm doing, I'm changing the origin of the this thing, so of the picture, right? So in other words, I'm going to get a new this thing. Wait, do write this over here. Wait, this is small x, small y, no? Okay, now I'm going to get a new system of equation, a new coordinate axis only, like you can say, where I've shifted my origin over here. Okay, so this is my capital X and this is my capital Y axis. Okay, clear? So draw this much of the picture, then we'll continue. Okay, so let us continue now. Okay, so we get this, right? So this is the change of variable which we are interested in looking at. Now let us let us go back to the lines which were given to us. Where were they? And randomly selected the numbers. Okay, so 2x plus 3y is equal to 5 and 4x plus 2y is equal to 3. So given, okay, I will write this all over again now. Wait. Given, we are given two lines 2x plus 3y is equal to 5 and 4x plus 2y is equal to 3. Okay, which are not passing through the origin. Okay, both of them are not passing through the origin and they are neither parallel. Okay, you can write sideways, which are not passing through the origin, 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 neither parallel. Parallel. Okay. So now their point of intersection is, which we calculated there, their point of intersection the point of intersection is, what is the point we found out? Minus 1 by 8 and 7 by 4, right? So let capital X be equal to small x minus 1 by 8, okay, and capital Y be equal to small y minus 7 by 4. Okay, keep in mind why I am doing a subtraction here. This formula can get a little confusing after some time because I am going to do some operations on it. So keep in mind, why did I do the subtraction over here? Why did I do x minus the point of intersection? Because I wanted to change the origin over there, right? So just going back to the diagram, what we were doing in yellow over here. Where was it? Yeah. So see, my intention was to reduce this value. I wanted capital X and capital Y to become 0, right, at the point of intersection h comma y. So that's why I've done a subtraction over here. Okay, keep in mind about that. Okay, so now, so if this is your substitution, then what will happen next? What is small x? Small x will become capital X minus 1 by 8. This is actually x plus 1 by 8, and this will become y minus 7 by 4. And small y will become capital Y plus 7 by 4. Taken the terms on the other side. Many people make mistake at this stage over here because here it is coming with a plus and here it was with a minus. Okay, so they write the plus sign here and then this they make minus, which will give you a wrong answer after some time. Okay, so this, right? So what are the equation of your lines? Substitute in the given lines. What is the first line? 2x. Yeah. So 2x, I'll write it as x minus 1 by 8 plus 3y, no? So y, I'll write it as capital Y plus 7 by 4 is equal to 5, right? And the second line becomes 4x minus 1 by 8 plus, what is the number? 2 times capital Y plus 7 by 4, okay, equal to 3, right? So simplify this equations. So this will become 2x minus 2 by 8, 3y plus 21 by 4 is equal to 5. Now notice one thing, just a trick for doing the simplification. If you have not seen this earlier, here the denominator is 8, here the denominator is 4, right? Okay, what I'll do is I'll better make, and here the denominator is 1. 5 upon 1 this is actually, right? So I'll prefer to have all denominators same, and the only possible number which I can make same is, this will become 1 by 4, no? So I'll prefer to keep everything with denominator 4, right? So this you can write it as 1 upon 4, and this I can write it as, this I'll multiply by 4 on top and 4 down. So this will become 20 by 4. So this is going to become 2x plus 3y. Take all the numbers on the other side. So 20 by 4 minus 21 by 4 and plus 1 by 4. Right, so this is 0. Four x, this can be written as 4 by 8. This will become 2y plus 2 into 4 by 8, 2 into 7 by 4. Okay, and this is going to be equal to 3, right? So this is going to become 4x plus 2y. I'll keep the denominator common as 2. I'll cancel hard things here, right? So this is going to become 2 I want, no? So this I'll write it as 6 by 2 plus, this is half, plus half, and this is going to become minus 7 by 2. Okay, thus 2 and 4 cancelled out here. So this is also 0 because 6 plus 1, and this is minus 7. So 4x plus 2y. Okay, so what are my new equations of lines? So my new equation of a line is 2x plus 3y, and you have 4x plus 2y. So what can you say about this new equations which I've got? This new lines are actually, the constants are same over here, right, compared to the original lines. What has changed? Only the constant has gone away. So you can say that this new lines which I've got in capital X and capital Y, both of them are passing through the origin, right? If both the lines are passing through the origin, what will be the point of intersection? The origin only, no, because they can't intersect at two places. Any lines, any pair of lines will either intersect at one point or they'll never intersect, right? So if they have one common point, that is the origin, both of them are passing through the origin because the constant term is not there. Okay, right? So their common point is now the origin. So that's what I've got by doing this. I've got them in the form y is equal to mx. Just if you shift this on the other side and divide over there, you'll realize that the equations are now in this form. Clear? Okay, so now why did we do this for differential equations? Okay, why did we study this in differential equations? Let us see this now. So consider the differential equation. Consider differential equation. Consider the differential equation dy by dx is equal to x plus y plus 4 upon x minus y minus 6. Okay, so what do we realize in this differential equation? Is it variable separable? No, right? You can't separate the variables on one side. Okay, so it's not variable separable. Is it homogeneous? Is this equation homogeneous? It is homogeneous actually, but only trouble fellow is the constant. If these constants were not there, it is homogeneous, right? Okay. If the constants were not there, then it is homogeneous. This part you should understand over here, right? So once you realize that the constants are the troublemakers over here, so what we should do? Our job should be the eliminating the constants, right? Okay. So we observe that if if we eliminate if we eliminate the constant terms, if we eliminate the constant terms, then eliminate the constant terms using a change of variables, change of variables, using a change of variables, then the equation will become will be a homogeneous one. Equation will be homogeneous. Okay. We realize that no, if it was only x plus y upon x minus y, then it would have been homogeneous. Actually, I think so. We solved that problem, no? X plus y upon x minus y. Yes, we have solved it. It was given as a homework problem. Just check. Or did I solve it in class? X plus y upon x minus y. The first one which I did, no? Yeah, so we have done it. So we know that if that 4 and 6 goes out of the picture over there, it exactly becomes one of the problems which we have solved before. Okay? So what we'll do is, now the question is, what is the change of variables required? Okay? So what change of variables will do to get the required form over there, in that form x plus y upon x minus y form. Okay, so what do we realize here is, based on what we just studied is, right, what do we see here is that this is an equation of one line. If you equate this to 0, it becomes one equation of one line, and if you equate this to 0, it becomes equation of another line, right? If you equate this to 0 and you equate this to 0, you get equation of two lines over here, right? So consider x plus 4 is equal to 0 and x minus y minus 6 is equal to 0. Okay, so this is a equation of two lines. Equation of two lines over here. Okay, what can you say about these two lines? What can you say about these two lines? Are they parallel or not? How do you realize the line is parallel or not to another line? If those coefficients of theirs are same, if a and b are same for both the lines, that means they are parallel. But it's not only a and b, they can be scalar multiples also. That we'll see tomorrow, that case. Okay, so but are they in that format? Are they multiples of each other? They are not equal to each other, right? That we can clearly see. Here it is plus 1, coefficient of x is here plus 1, here it is plus 1 also again, but here y is 1, here it is minus 1. Okay, so a into e, one second. Yeah, they are not multiples of each other also, because here it was 1 comma 1, here it is 1 comma minus 1, so it's not a multiple line. Okay, so this is an equation of two lines which are not parallel. Okay, how did I come to know their lines are not parallel? Because here the coefficients are different. But anyways, the faster check is checking. How do you check two lines are parallel? Checking ax plus by plus c is equal to 0. This we should have done first. So I'll just do it here. A1, b1 and c1 is parallel to a2x is b2y. Okay, how to check these two lines are parallel? If they are this thing, consider the determinant a1, b1, a2, b2. Okay, consider this determinant of their coefficients. Okay, now find out this determinant value. Okay, so we'll call this as d, capital D, determinant. So if determinant is equal to 0, then the two lines are parallel. Two lines are parallel. If determinant is not equal to 0, then the two lines are not parallel. In other words, two lines intersect somewhere. Okay, in other words, they are not parallel. Yeah, now I can't explain to you geometrically what is determinant right now. That you will learn much later on. Okay. Now what did I say? Two lines are parallel if the coefficients are same. So now if you write a1, b1 and a2, b2 as same numbers, determinant is 0. That you all know, no? If two rows in the determinant are same, determinant is 0. What are the other cases when determinant becomes 0? Talking row wise, don't check two columns are repeated. When else do the determinant become 0? One is that entries are same. Okay, basically the first row and second row are same, determinant is 0. What is the other case? Yeah, but if the terms are 0, if a2 and b2 are 0, there is nothing for us to talk about here now. So that case won't arise. See, if a2 and b2 are 0, and then you'll write an equation as c2 is equal to 0. So that c2 is also 0 by the way. So it's not a line, it's not an equation of a line, no. So other than that, so that case is not relevant here, that both the entries are 0. One full row being 0 will give the determinant 0, but it's not relevant to what we are talking over here. It will not happen here. Okay, what other cases there? Three cases are there. One is the same, one is 0, and one is, what is the next one? You will have scalar multiples, no? Scalar multiple of a row. So if the second row is a multiple of the first row, then it will become determinant becomes 0. Basically, you will have learned this property indirectly. See, what I'm saying is, see if my entries are like this, if a2 is a scalar multiple of k times a1 and b2 is k times k times b1. Okay, what will be your determinant you're calculating there? It will become a1 b1, okay, and a2 b2. This will be equal to a1 b1 k times a1 k times b1. This determinant will be 0, no? Why will this determinant be 0? What property is there now? You can take the k out common, no? When you're calculating determinants, you can take one common, this thing, if the element is common, you can take it common. So this becomes k times a1 b1, a1 b1, right? So this determinant, as she said, already is 0 because the entries are repeated. right? So hence it will become 0 into k, that will give you 0. Okay, clear now? So if the determinant is 0, the lines are parallel. Okay, basically the coefficients are the same thing, either they are exactly same or they are multiple of each other. Okay, some k times the multiple of the first one. Okay, and if they are not equal to 0, that means the lines are intersecting. Okay, clear now how to verify whether two lines are this thing? You all will do a theorem, the theory behind this determinant formula you all will do in that geometry paper, how it is this thing. But this much properties of the determinant you all understood, no? If their numbers are same, then the determinant should be 0. Okay. Yeah. So now, yeah. So because of this, now verify this property over here. Calculate the determinant of this coefficients. What is it? Here it is 1, 1, 1 minus 1. Okay. So calculate the determinant, what it will be? Minus 1, minus 1. Minus 2 will be the value, right? Which is not equal to 0. So for this case, the determinant over there turns out to be, yeah, this is the end of that part. So continue. So for x plus y plus 4 and x minus y minus 6. Here the determinant is defined as 1, 1, 1 minus 1, which will be equal to minus 2, right? Which is not equal to 0. Hence the lines are intersecting or they are not parallel. Okay. This determinant you all should be able to calculate in your mind only. Okay. By the way, for a 2 by 2 determinant, the formula is very simple, right? So determinant equal to 0 means what? Determinant equal to 0 means over here you are talking of a1 b2 minus a2 b1, this is equal to 0, right? So in other words, if a1 times b2 is equal to a2 times b1, then we say that two lines are parallel. Or in the other case, that is a1 b1 a1 b2 is not equal to a2 b1, then we say that the two lines are intersecting somewhere. Okay, in the book it's written like this, this condition, but I know that this condition comes from where? From the determinant. So it's better you'll remember the determinant, not this formula. This is a very weird formula if you try to remember it. Okay. So in this book they have not gone too much into the geometry the way I have shown it to you all. They have just said that if this equation, that is if a1 b2 is equal to a2 b1, then the lines are parallel. Okay, now why this formula is given, that they have not explained, but I have told you that this is the formula, comes from a determinant. So it's better you'll remember the determinant than remembering this weird expression. Okay, this is a very weird expression to remember, no? Okay, keep in mind it comes from a determinant and calculate the determinant. If the determinant is 0, then it is parallel, not 0, they are intersecting somewhere. Okay, just to give you all a brief idea what is going to come somewhere later on, no? Okay, this is going to come somewhere later on in your 4th semester or something, that what I have studied determinant is, by the way. So determinant for you all in 12th standard is taught as a function which takes a matrix to a number, right? So if you are given a square matrix, you can convert that square matrix into a number. That's what is the definition of determinant for you all. But actually determinant is actually a volume of a function, okay? So that function, those matrices which you all were calling as boxes of numbers, no? Those matrices are actually functions. Okay, in 12th standard they are just told to you all as boxes in which you all have put numbers and kept, no? Actually they are functions. How to use this function, what is the behavior of those functions, and why those functions are actually functions, that you all will be learning in somewhere later on in linear algebra. Okay, so linear algebra course is there, so that time you all will be taught that matrices were not boxes of numbers but they were actually functions. Okay, yeah, that is if you all study the course with proper attention. Okay, so if you all study the course just for the sake of passing the exam, you all will never realize that the theorem has come and gone also. Okay, yeah, majority students study this course but they never realize that. Okay, but just keep in mind that those matrices are, yeah, and some of those people actually go on to become teachers also in maths. Yeah, so anyways, uh, yeah, so keep in mind that those matrices which are learned were actually functions, okay, which are operating on some set, okay, and the determinant actually calculates the volume of its image, okay. So this number over here refers to some volume over here, okay. It's not volume in this sense, it's an area, okay. Okay, but now how to relate that with all these quantities which are talking right now, it's a lot of theory involved, so I won't get into that, but just saying that. Okay, so after you'll get understand linear algebra, you will understand better what was going on over here in this calculations. But for the time being, just will keep in mind that the determinant is not zero, means it is lines are not parallel. Okay, so now since the lines are not parallel, what we can do? We can find the point of intersection. Okay, find the point of intersection over here. So x plus y is equal to minus 4, and you're given that x minus y is equal to minus 6. Okay, solve these equations and get the point of intersection. Okay, so how will we proceed? Just try to go with the method which I told you earlier. Our job will be to kill this fellow over here. Okay, so we'll kill this fellow and make it 0 over here, and accordingly we'll get a new system of equations. So x plus y is equal to minus 4. Yeah, if you don't like the word kill, we use the word eliminator. So we eliminate this fellow from here and we'll get a new set of equations. So how we'll eliminate it?
So it's plus 6 now.
Ah, yeah, sorry, this will be plus 6. Yeah, so yeah, how do we eliminate this fellow? Just subtract the, this is a very easy equation, no? So subtract the first equation from the second. So that will leave you with minus 2y is equal to 10 over here. Okay, so you get that. So you conclude that. So you conclude that y is equal to minus 2y is equal to 10. So this leaves you with y is equal to minus 5. Right? So substituting in the first one, y is equal to x plus minus 5 gives you minus 4. Right? Take minus 5 on the other side. So this leaves you with x is equal to plus 1. Right now? Plus 1 minus 5. Yeah, correct. Yeah. So what is the point of intersection for us? A point of intersection is the point of intersection of two lines the point of intersection of two lines is 1 comma minus 5. By the way, in 10th standard you will have learned how to solve this equations, no? What you will be actually doing over there is you will be finding the point of intersection of those two lines. Whatever you all did in that 10th standard is solving a system of equations and all, you will be finding the point of intersection of two lines, and three variable case you will have not done, no? Ax plus by plus cz. You are given this a2x plus b, this is equal to d, b2y plus c2z, b1, and this is d1, this is d2, and this is a3x b3y plus c3z is equal to d3. This you will have not learned how to solve, no? You will learn this. Yeah, you can solve this using some determinant method. Actually, if the determinant is non-zero, then you can find the inverse of a matrix over here. You'll have seen that. It's not done in 12th standard. No, I think so. It's done as an application of matrices. No. Yeah, application of matrices. You are solving this. You will find the coefficient matrix over here, matrix of coefficient A, and if that matrix is having non-zero determinant, you will reduce this to the form Ax is equal to B. where x is the coefficients x, y, z, and then you will take, a is non-zero determinant, you take it on the other side, right? So x is equal to b times, sorry, a inverse b. Okay, so that becomes a solution. Yeah, basically here what you will be doing is you will be finding the point of intersection of three planes. This is the equation of planes, right? Okay, so what you did here is that x, this x over here is the point of intersection of the three planes, and if you are doing it with two variables, it's actually a point of intersection of two lines. Okay, irrespective of whether you all talk of it like that or don't talk of it like that, it's actually happening there behind the scenes. Okay. So anyways, just keep this aside. Yeah, so what should be a change of variable now for this problem? I'll say my capital X is, we change the variable, we perform a change of variable, change of variable. What is the change of variable? Capital X should be small x minus the point of intersection, that is 1, and capital Y should be small y minus the point of intersection, that is minus 5. So this will leave you with x minus 1 and x y plus 5. But for the sake of substitution, we have to go the other way around. We require small x is equal to capital X plus 1, and we require small y is equal to capital Y minus 5. Okay. So this will be a change of variable. So what are the lines given to us? X plus y is plus 4 is equal to 0, and we are given the line, second line is x minus y minus 6 is equal to 0. Okay, so perform this change of variable over here. Small x will become capital X plus 1 plus capital Y minus 5 plus 4 is equal to 0. This will become x plus y 1 minus 5 plus 4, so that is 0, no? And this will become x plus 1 minus y minus 5 minus 6 is equal to 0. So this will leave you with x minus y 1 plus 5 minus 6. So this will become 0 again. Okay. So the new equation system of equations we have is x plus y is equal to 0, and we have x minus y is equal to 0. Okay, so this is a new system of equations. Now we were talking of a differential equation over here. So if you're performing a change of variable here, if you're changing your x is changed to this thing, no? What was x changed to? Capital X minus 1 and capital X plus 1, it was, just check. Yeah, capital X plus 1 and small y was changed to capital Y minus 5. So your dx becomes over here, you take derivative on both sides actually, so your dx becomes capital dx and small dy becomes capital dy, because if you take derivatives over here, that 1 will go away. Yeah, how did I take the derivative over here, by the way? I have done some mischief here which I have not explained to you all now. You all can just believe this for the time being, that if you take the derivative of this equation, what will be left out with is small d. In other words, you know what, you all can think of it like this, that I have taken the derivative here of capital Y, capital X with respect to small x. What will get then? This will become 1. You have x is equal to So take derivative of capital X with respect to small x. So what will become? This will become 1, no? Derivative of small x with respect to small x is 1. Derivative of capital X with respect to small x will become this. And this will become 0. So if you rearrange it, it becomes this. Okay? Same thing you do for the other one. Huh? Okay, so small y, capital Y minus 5. So this you can write it as 1 dy by dy minus 0. Okay, so it will become this if you take the term on the other side. Okay, so what will be a given differential equation? Thus given d will become, you have capital dy by capital dx x plus y upon x minus y. Okay, so after doing all this trouble over here, so do we have a which is a homogeneous D? Okay, this is a homogeneous D that you all can verify. Okay, this is a homogeneous D. We have actually seen it before, so I won't emphasize on how I verified that, but you all can verify this for homework that this is a homogeneous one. Okay, this is homogeneous of order 1 actually. What do you call that? Homogeneity is 1. Degree of homogeneity is 1 over here for this equation. So now what do we do next? We put what's the change of variable we were doing? Yeah, we were putting z is equal to y by x. No, so we'll put now capital U is equal to y by x. Okay, we put capital U as y by x. So capital du by capital dx. This is same as writing ux equal to y. So capital, taking derivatives on both sides. So dy by dx, this will become u plus x times du by dx. Okay, same thing what I had written in small alphabet, I have written it capital alphabet. Nothing has changed now. Okay, yeah. So and the given equation, this was x plus y. This can be written as, so thus the given d becomes u plus x du. Oh, I'll have to write it sideways. Huh? My page got over. Thus, the given differential equation becomes u plus x du by dx. This is equal to, it was 1 plus u and upon 1 minus u, right? Dividing by x over there, you'll get this. So x du by dx 1 plus u, right, capital U, I make the mistake, minus u. So simplify this, this will become 1 minus 1 plus u minus u minus plus u square upon 1 minus u. So this becomes 1 plus u square upon 1 minus u. I'm correct with this calculation? Calculation is correct, no? Okay. So du upon dx. Okay, my page was over here. So it becomes a variable separable now. So it's variable separable at this point. So what do I have here? I have 1 minus u upon 1 plus u square du and then upon dx by x. Okay, this I know can be integrated by writing it as 1 plus u square, okay, minus u upon 1 plus u square, separating the numerator du, and this is 1 by x times dx. Okay, now I'll do this directly, right? I know that this is integral is tan inverse of u. This integral over here is the numerator can be expressed as derivative of the denominator. So what I should do? I'll write it as 2 times 2 over here. Okay, I'll balance the 2 over here. So numerator is 2 times the derivative. Sorry, numerator is derivative of the denominator. Right. So I'll do it directly now. Okay, I won't write down extra steps. There are no marks for this integration, so try to make it as short as possible. Okay, only a final answer matters to me. So that is tan inverse of capital U, and this is derivative of the thing. So it becomes log of half is the outside. So it becomes log of modulus of 1 plus u square. Okay, and this is log of capital. This write is as ln. Ln of x plus ln of c, the constant. Okay, so the answer here will become tan inverse of u. I'll take this terms on the other side. Okay, so I have here half times ln of 1 plus u square modulus. Alright, modulus here. C you can ignore. And this I have can write ln of modulus of x plus ln of c. Okay, I'm continuing again here. So I'll get tan inverse of u is equal to capital U. This is equal to ln of half was there, so that will become square root, no? Square root of 1 plus u square okay. Ln of half means it will become 1 plus u square to the power half, which is square root. Okay, and this will become, I'll combine this directly, these two terms. This is ln of x into c. Okay, combine this again. This will become ln of x times c times root of 1 plus u square. Okay, and this is tan inverse of u. But what is u? U is y by x, right? So this will become tan inverse of capital Y by capital X into ln of x times c times root over 1 plus y by y square by x square. Keep in mind that the square root applies for the whole thing over here. You can simplify this, no? You can take x square on top, so it will become x square plus y square divided by x square. But that square root sign you apply to the denominator, that will leave you with x over there, and there is an x here, right? So I'll cancel it. So I'll just explain it in rough what I did. This can be written as x square plus y square upon x square. So applying this thing, square root separately, x square plus y square upon denominator root of x square will give you x, x will cancel. Okay, so I left out with only this expression. Okay, it's become very lengthy and my page is over actually, so right sideways. So tan inverse of y by x, okay, into ln of c times root over x square plus y square. But now, what is capital Y? What is the capital Y expression? Y minus 5, no? No, sorry. Capital Y is small y plus 5 divided by x minus 1, right? And ln of this thing is c root over capital X is, yeah, small x minus 1 the whole square plus y minus y plus 5 the whole square. Do you all recognize this person? Do you all know what equation this is? This is the equation of a circle, right? If you equate it to something. No? You don't know that. This is the equation of a circle, no? X minus a the whole square plus y minus b the whole square is equal to r square. This is the equation of a circle with radius r and center a comma b. So in this case the center is 1 comma minus 5, okay, and some constant will be there, okay. So this represents equal, there is no equal to r square here, but it is indirectly somewhere going to be there, okay. If you simplify this actually further, you'll get something. Okay, so this is the equation of one circle here. What was the solution of that problem which we solved previously? The first problem which I gave you all, with small x and small y, small x plus y upon small x minus y. What is it? Then find. I'll really end up in finding it here. Yes, see, this one I'm talking about. See, I found it before you all. What is the final answer? This is the answer. Oh. Okay, here the answer is written somewhere here. No, not here also. Oh, we didn't answer. Go here. ZX. No, I can't find the answer. I think so. I scrubbed it out by mistake. Yeah, what was the answer? Oh, 10 inverse was then that problem, the solution. Yeah, it should have come something similar. But never mind, we'll look into that later. We didn't make a mistake while solving this, no? The answer should have been something similar. And what about the other side? Something like that. It should have come like that, similar. Because see, I solved the same differential equation, no? What was the answer over the show? Oh, I made a mistake while solving that. Plus minus. Hey, this one we solved correctly, Mare. So solving here. Oh, is it the same differential equation? But no, it's not the same. It's not the same one. There you have x minus 1, the x minus 5 in the numerator. So the answer will be different, yeah, obviously. He's saying that I made a mistake when I was solving that. I just check. He's saying when I was solving that problem in class, there is a small mistake in it. Just check the number. Okay, anyways, this is the answer which we get to the given differential equation. So to this given question of ours, this is the final answer. Okay, there are some 10 minutes more. We'll solve one more problem in 10 minutes. It took a lot of time to solve this one. Okay, so let's go fast and solve one more problem. Go to a new page. So the given question is dy by dx is equal to x plus y minus 1 upon x plus 4y plus 2. Okay. Okay, so this appears to be a homogeneous, take this as a second problem. This appears to be a homogeneous equation, right? But only problem is there are these constants over there. Why I am saying it appears to be a homogeneous? Because degree of x and degree of this terms over here is same. First degree, first degree here. Okay, all terms are first degree only, except for these constants which are 0 degree terms. So if you can eliminate these constants from the picture over here, then we are done with the problem. Okay, so then we can solve this problem fast. So let us do it fast. Consider solution. Consider the system of equations. X plus y is equal to 1. I'm taking it on the other side, and x plus 4y is equal to minus 2. Okay, so what is the determinant of the coefficients over here? The determinant value is going to be 1, 1, 1, 4. Okay, so this will become 4 minus 1, which is equal to 3, which is not equal to 0. Okay, it's not equal to 0, hence the lines intersect. And as I told you also, the coefficient numbers are different here. This is 1, 1, 1, 4. So they are not same. They are not multiples also. So they are going to be intersecting. Okay, hence the lines are intersecting. Okay, so find out the point of intersection. We'll try to eliminate this coefficient over here. And it's a very easy elimination because the numbers are same. They have given us easy problems actually. So finding the point of intersection. Intersection x plus y. Okay, subtract this is 1. So subtract this from this. This will leave you with 3y is equal to minus 3. So we'll get y is equal to, left with y is equal to minus 1. So putting y is equal to minus 1 in that first equation, x plus minus 1 is equal to 1. This leaves you with x is equal to 2. Yeah. So x is equal to 2. So your point of intersection is what? 2 comma minus 1 is your point of intersection. Okay, so what will be the change of variable which we want to do? Change of variable which we want to do is x, small x minus 2, and capital Y will be small y minus 1. And this will become small y plus 1. Okay, but for the sake of our substitutions, we require x is equal to capital X plus 2 and small y is capital Y minus 1. Okay, so I won't go to finding the equation of lines and all. Okay, so we'll directly proceed from this point. Okay, so if x is this, change of variable is this, no? So let x be equal to this. So what will be our dx? Dx will become capital Dx, d small dy will become capital Dy. Okay, and then the given equation, yeah, don't do all the steps which are shown here in the last problem to explain. Directly we'll proceed. So given d becomes capital Dy, capital Dx. Okay, what is it? This will become x plus 2 plus y minus 1 minus 1. Even this step you all can skip, because just replace the small alphabet with the capital alphabet. But don't do it directly, because this step will show you whether your calculations are correct or not. Okay, so this step you will purposely do even though it can be done directly. So 4 times y minus 1 plus 2. So x plus y plus 2 minus 1 that will go down to 0. So x plus 2 minus 4 plus, yes, it's x plus 4y it is. Okay, why I'm telling you to do this step purposely, no? Because in case you have made a mistake somewhere in the finding the point of intersection or making this defining this values over here, if you make a mistake at this stage, you will not get this constant 0 over here. Okay, that means you have made a mistake somewhere. Okay, you can go back and verify where the mistake came. But if you directly replace small x with capital X over here in the given differential equation, you all will not know that you all have made a mistake. You all will continue solving a wrong problem only. Then your final answer will come with a mistake. Okay, so the given d becomes this, right, which is dy by dx. I'll divide by this thing, so this is y by capital X and this is 1 4 times y by x. Y by x, yeah. So put, again we are performing a second change of variable now. So put u is equal to y by x. By the way, I had done the initial problems with u only, no? Not z, no? I didn't use z for some other reason. U only I have done, no? The first problems of homogeneous something. Z I had done. Why did I use u here? So we'll use z here also then. In 12th you studied them with a u, no? V. Yeah, V is taught over there. Why did I use a u in the previous one? I don't know. Let it be with z only then. I don't know why I used u there. Okay. Yeah, put z is equal to this. Zx is equal to y. So you'll get your dy by dx is equal to z plus x dz by dx. Okay. So finally, the given differential equation will be z plus x dz by dx, okay, 1 plus z upon 1 minus 4z. 4z. Okay. So x dz by dx 1 plus z upon 1 minus 4z minus z. So this will become 1 plus z minus z plus 4z. 1 minus 4z. Okay, there is no quadratic term here, no? So, 4z square. Okay, so this will become 1 plus 4z square upon 1 minus 4z. X dz by dx. Okay, clear now simplification?
So it is 1 plus 4z, no?
Where?
The denominator.
Oh, I started wrong. Both way plus. Sorry, I copied it wrong from there. So this is plus, so this is minus, this is plus. So this is minus, yeah. Minus, this is plus, this is minus, minus, plus. Correct, no? Okay. So this will become 1 plus 4z. So I can do this like this, 1 minus 4z square, split it, and this will become 4 times 1 minus 4z square upon z. Okay, my intention here will be to make the numerator the derivative of the denominator. So I'll have to balance this with a, there is a 4 already here, right? So this I'll balance it with a minus 2 here on top and divide it with a minus 2 here down. Okay, so derivative of this will be minus 8z, right? Okay, so minus 8z you have here and minus 2 down in the denominator, and this will be tan inverse. This will be tan inverse. So now here what we'll have to do? This is not tan inverse, not directly, so we'll have to take the 4 common out. Right now everyone agrees? Take the 4 out common, minus 4 out. No, it's 1 minus, no? Oh, we have to do partial fractions, you have to split it and do partial fractions. Anyways, there's lots of work here now. So what is this actually? You can think of it as, we'll take this as I1 and I2. Okay, so I1 calculations we'll do here. So here you have 1 minus 4z square, right? Capital. I write my capital Z like this. So now it starts looking like a 2. Okay, so take care. See, my Z has sharp edges here. My 2 is like this without sharp edge. I can make out the difference here. You all should be able to. Okay, so yeah. This you'll write it as, take the 4 out common. It will always be better. So this will become 1 by 4 minus z square. Now this I'll write it as 1 by 4 over here common outside. This can be written as half times minus z into half plus z, capital Z, minus capital Z plus capital Z. Okay, which formula did I use here? A square minus b square is equal to a plus b into a. Clear? Yeah, now since this is of a monic coefficient, no, the coefficient of z is 1 here, it becomes very easy to do partial fractions. Had you kept that 4 around, no, little trouble would have been there. Little, not much. That final answer had to be divided by 4 anyways. So simplifying further, you have to go for partial fractions here. So 1 by 4 times this partial fractions, let me do it directly. See, I'll directly write it like this. Okay, and then here I'll write this. What I have to think of is only the coefficients to balance these terms. So if I cross multiply them on top and add them, what will come? Z and Z gets cancelled, right? And half will add up, will give you 1. So directly I have to put a plus sign here. Okay, so if you will do this by partial fractions, a and b value should come 1. Okay, just to explain again what I did, I had written the numbers like this only. If I cross multiply them, the denominators will get multiplied and give you this. Numerator should come 1. So this will go on top, it will become half plus z, and this will go on top here, this will become half minus z. So z and z will get cancelled, z and z is cancelled, half plus half is becoming 1. Okay, so directly it is this. So the integral over here will become 1 by 4 times ln of, by the way, this will become a nuisance to integrate. So just write this like this. Z plus half minus z minus half. Otherwise you'll have to balance that minus sign while integrating. So it's better you write it like this. Okay, it's the same thing, but better you write it like this. Because if you try to integrate this now and you forget to write it minus sign, no, then your answer will be wrong. Okay, so convert it in this form and then write it. So this will be half times 1 by 4 times bracket ln of z plus half minus ln of z minus half. But we know that this can be simplified, right? This is going to be 1 by 4 ln of modulus of z plus half upon z minus half. This can be simplified further. What we will do next? Multiply numerator and denominator by 2. So this will leave you with 1 by 4 times ln of 2z plus 1 upon 2z plus 1. Sorry, minus 1. See, my 2 looks like this and my z looks like this. When I write them side by side, it's very clear. Okay, so this is my calculation of I1. Yeah, you all can write this as capital Y by capital X. We'll do that later in the final steps. What is I2? The I2 integral was what? So you all do it below, don't this. Don't do side by side, you all do it below. I2 was 1 by 4 times z upon 1 minus 4z square, right? Yeah, so here I'll balance it with a 2. Oh, sorry, it's 4 in the numerator. Oh, it's 4 in the numerator, not denominator, no? Sorry. 4z it was the question. So I'll keep this 4 out common. I'll balance it a minus 2 up, minus 2 down. 4z minus 4z square. Okay, so this will become minus half. You keep it out, this I'll write it as minus 8 times z upon 1 minus 4z square. So now you can clearly see that the numerator is the derivative of the denominator, right? So this should become minus half times, integration should become minus half times ln of 1 minus 4z squared I2. So final answer will be I1 plus I2. What will that be? This is 1 by 4 times ln of 2z plus 1, and I2 was half times ln of 1 minus 4z square. Okay, so what should be our final answer, by the way? We came very far away from what we were doing. On the other side we'll be getting ln of x, right? Ln of x into c. So I'll directly write that. Okay, so final answer, this is not the final answer actually, but still, this will become 1 by 4 times ln of 2z plus 1 upon 2z minus 1 into half times this. This can be simplified further, but let's not simplify this, because this will have to involve a lot of divisions and all. And this RHS over here will become ln of x into c. Okay, this is very obvious part. Okay, now resubstitute over here. This will become 2 times y by x. Okay, but now based on our experience, can we write this directly like this? What I have done is I have cross multiplied the denominator x and cancelled it with the other x which comes from down. Okay, so half times ln of, here also I'll try to do the same thing. This will become y square by x square, right? So I'll take that x square here. So x square minus 4y square divided by x square. Okay, and this is equal to ln of x into c. Okay, still we are not done with this. We have to substitute one more time. By the way, this could have been simplified, but I'm not doing that simplification. This 1 by 4 outside should become a fourth root of this expression, and this should become square root of this expression. But it will not help us in any way in cutting out any term. Okay, so let's not do that. So just going back, this is half times ln of 2 times, what was that thing? What is the change of variable? Small y plus 1, and the other one was what? X minus 2, small x. Okay, so 2y plus 1 minus x minus 2. Okay, half times ln of x minus 2 the whole square minus 4 y plus 1 the whole square plus, and this is equal to ln of c times x minus 2. Okay, so this entire expression is your final answer. Okay, it can be still simplified further, but let's not do that. Okay, so this is the end of this thing. Okay, I'll give you one problem for homework. Do try that out. Uh, Problem for homework based on this homework problem. This is written as like this, but 2x plus 3y minus 1, 2x minus plus 3y minus 1 dx minus 4 times x plus 1 dy is equal to 0. 2x plus 3y minus 1, 4x plus 1, 4 times x plus 1. Okay, solve this one for homework. Tomorrow we'll continue with this technique. Tomorrow we'll deal with the situation when the two lines are parallel. Okay, so today we dealt with the situation when the lines were not intersecting. Okay, so we'll stop with this for today.